Hi everyone. So today we are beginning our Unit 4 review in preparation for your unit test at the end of next week. We are starting with reviewing Unit 4.1, so you don't need to retake these notes. I'm just going to take us through a couple pages of the notes that you've already taken to summarize the important points from this subunit and then give you a couple IXLs to work on. First, I want to say that I am really disappointed because only 10 people watched the last lecture that I had posted as of right now. So this is Wednesday night that I'm recording this, and the lecture was posted on a Monday. And if that number of views doesn't get to about 50 consistently, I'm going to stop making these videos, and you all, I'm just going to link Khan Academies for you to watch, because it's really not a productive use of my time to continue making these if you're not actually watching them. So if you watch these consistently and you think that you get a lot of value from them, please make sure that you're telling your friends that they need to be watching them. For those of you who watch these consistently and really rely on my explanations, know that if we have to switch to a Khan Academy system, I am more than happy, and I actually want to explain things to you, so feel free to FaceTime me and I can explain things to you myself, but it's not really worth the process of taking the video and uploading it to YouTube. It's a pretty long process just to have 10 people watch it. That being said, thank you to those of you who do watch. We are in the 4.1 subunit packet, as I said. We are going to start reviewing on page 8. Actually, no, we'll go back to page 7 to review the different angle relationships. So vertical angles are the ones that are across from each other, and they are congruent. Adjacent angles are angles that are next to each other and share a common side. So that is the key there. They share a side. It's like next door neighbors who share a fence. Those would be adjacent, and vertical would be neighbors across the street from each other. Complementary angles are any two angles whose sum is 90 degrees. These angles can be adjacent, so it can be a right angle that is just cut into two, or they can be vertical angles that are both 45, or they can just be two angles that together add up to 90 degrees. So you could have like a 50 degree and a 40 degree. The only rule here is that they add up to 90, two that add up to 90 in any arrangement. Next we have supplementary. This is when you have two angles whose sum is 180. Again, they can be adjacent, meaning they can just be a line. They can be vertical and both be right angles, or they can just be independent angles that add up to 180 degrees. So you could have like a 100 degree and an 80 degree. Lastly, we have linear pair. These are two angles that are both adjacent and supplementary. So it's really just only a straight line. Does it have to be a vertical line or a horizontal line? Just any line. So those are your angle relationships. If you need extra practice, you have all of the pages of your notes that you can reference. Also, if you don't have your notes, you can look back on Google Classroom, because this packet was posted for you. This was the first time that I posted a packet, so you can go back and find it on Classroom. So we are going to move on to, well, first let me just say that you need to be able to use those relationships to find missing angle measures, right? So for number 1 here, we know that these angles add up to 90 degrees because of the box. They're complementary. So if you know one is 65, you find the other one. Here you know that they're supplementary. Here you know that 107 and y are vertical, but that x and z are vertical. And then you know that x and y, or 107 and z, or x and 107. You know, any set of those pairs are supplementary because they're a linear pair. So make sure you are looking back on that. Next, we're going to talk about transversals. So when we have transversals, which are, a transversal is just a line that intersects two or more lines, all right? So those two lines, L and M, they are not the transversal. T is the transversal. Whenever we have a transversal intersecting two or more lines, it creates angle relationships or angle pairs. So corresponding angles are angles on the same side of the transversal and in the same position. So same side meaning left or right, same position meaning up or down. So I'm not going to do all of these, just like one example of each to jog your memory. So left and up is 1 and 5. Right, they're both to the left of the transversal and above their specific line. Alternate interior are both on the inside, meaning if your two lines are like pieces of bread, everything that would be inside, like the sandwich, that's your interior. So the 4, 3, 5, and 6 are interior. Non-adjacent, meaning they're not next to each other. So 4 and 3 are not alternate interior. 5 and 6 are not alternate interior. So we know they have to be inside, but they can't be next to each other. They also have to be on opposite sides of the transversal. So 4 is on the same side of the transversal as 5. The only other interior angle that 4 is not adjacent to and on the opposite side of the transversal to is 6. Next, we have alternate exterior. So same idea here, but they are on the they're the exterior angles. So 1, 2, 8, and 7. But again, non-adjacent and on opposite sides of the transversal. So adjacent would be like 1 and 2, right? They share a side, they're next to each other. And on the same side of the transversal would be like 1 and 8. So the only one that is opposite exterior to 1 is 7. Next, we have consecutive interior angles. These are angles that, interior angles, meaning on the inside. Our options are 4, 3, 5, and 6, that are on the same side of the transversal. So if we're looking at 3, there's only one other interior angle that's on the same side to the right of the transversal, and that is 6. All right, we're going to fast forward to parallel lines and transversals because as I hope you remember from when we actually did this unit or subunit, that the only reason that we learn about transversals is so that when we introduce parallel lines cut by a transversal, we get some congruency or some supplementary angle pairs that can help us when down the road we do proofs. So each pair of, back up, if you have two parallel lines that are cut by a transversal, so looking at example 1, right, we do have two parallel lines. We know that because these little arrows mean parallel. All right, two parallel lines cut by a transversal. Each pair of corresponding angles is congruent. So corresponding being like 1 and 5, or 2 and 6, or 4 and 8, or 3 and 7. Each pair of alternate interior angles is also congruent. So like 4 is congruent to 6, 3 is congruent to 5. Each pair of alternate exterior angles is congruent. So like 1 is to 7, 2 is to 8. And each pair of consecutive interior angles is supplementary. So consecutive interior being like 3 and 6, 4 and 5. As we remember from earlier in this lecture, vertical angles are always congruent and a linear pair is always supplementary. So these two pieces of information are not in relation to the transversal, but just angle relationships. So for number 1, if we're told that the measure of angle 1 is 65 degrees, there's a lot that we can do with that. So if we want to go in the order here, we can find the measure of angle 2 because 1 and 2 are a linear pair, and a linear pair is supplementary. So 180 minus 65 is 115. Linear pair to angle 1. You could have done that and found angle 4 instead, right? Because 1 and 4 are also a linear pair. 1 and 3 are vertical. So that's what makes 3 65 degrees. Again, you could have done 2 and 3 are a linear pair and found it that way. It's all very cyclical here, guys. Like, there's a million ways to get to each angle. Number 4 is vertical to 2. Oh, I said vertical 2. That's weird. Okay, vertical to angle 2. And then we have angle 5, 6, 7, and 8. That's like our different train station, if you remember that analogy. That each line, so we can call this line A and line B, right? That's like a street. And the transversal is like your train. And your train is taking you from the stop on A street to the stop on B street. And each train station, A station and B station, has 4 places you can get off, right? Because that's how train stations work. You can get out at one of several exits. So 1, 2, 3, and 4 are exits of A station. 5, 6, 7, and 8 are exits from B station. So you don't need a transversal to get from 1 to 2 to 3 to 4, right? That's just a different exit of the same station. But if you're trying to get to 5, 6, 7, or 8, you do need to take the train because that's a different station. All right, so in order to start talking about those bottom numbers, it's a different train station, you need to involve the transversal. Involving the transversal means you have to start using these, right? Vertical angles aren't going to cut it anymore, and linear pair is not going to cut it anymore in relation to 1, 2, 3, and 4. All right, you have to use one of your transversal relationships to get to the bottom. So if you want to start with 5, you can, right? You can say that 5 is alternate interior to 3. You could say it's corresponding to 1. It doesn't matter. It's going to be 65 degrees either way. You can just pick which one you want to use. From there, you can use vertical or linear pair within this little area, right, within the same train station. You don't have to. You can go back to your transversals, but you can, all right? For 6, I'm going to say that it's congruent to angle 2, 115 degrees, because they are corresponding. But again, you could have said that it was congruent to 4 because they're vertical, or it's a linear pair with 5, right? All the same. To angle 2. For 7, you can say that it's vertical to 5, or that it's alternate interior to 1, or that it's corresponding to 3, right? I'm not going to write those down anymore because there are just so many reasons you could use. For number 8, 115 degrees for one of many reasons, alternate interior to 2, corresponding to 4, vertical to 6, etc. So as long as you have reasons that are valid, you're good. But the really big thing that I want to say is that once you're getting, or say again, I already said, once you're going from this station to this station, you need one of these. At some point, you need one of them. All right. So that is all I have for you. If you need some additional practice on this, please just do some problems in your packet. You have most of them filled out already, so you can just do them on a separate sheet of paper, and then check against the answers and work that you already have. Also, feel free to let me know if you need some extra help. Please don't put this off just because your test isn't for a week. We are reviewing a new thing every single day, and you don't want it to compound and become too much for you to study. So if you need help, get it now before we move on. All right, that's it. Again, if you want me to continue the lectures, if you're someone who gets use out of them, please tell your friends. the same note there. If you don't get use out of them and you just watch them because you're a good student and you're told you need to watch them, but you think that a Khan Academy lecture would be just as useful to you, please tell me, because it's really disheartening for me to spend time prepping for the lectures and recording them and uploading them for, not that many people to watch them. So let me know either way, or let your friends know. But yeah,